All right, so 3-1, quadratic functions. So again, quadratic functions are just going to be parabolas, or the x squareds. And hopefully you all remember the general shape of these, right? Because we were transforming them all over the place for the last test, or last section, last test. So typically, so if you have y equals x squared, or f of x equals x squared, then you're going to have a parabola. Its vertex is going to be at 0, 0, and it's just going to open up. And we can plug in points. So we could plug in, if we did that x is 1, and we square it, we're going to get 1. So we know we have the point 1, 1. We can do 2. We know we'll get 4. Square 2, you get 4. We'll also realize that because this is being squared, if we plug in -1, if you square -1, you also get +1. And if you square -2, you still get +4. So these things, which you probably already figured out, but they're symmetric about the line running through the vertex. So the vertical line running through the vertex. Basically, you can just fold it on top of itself, right? So the vertex is going to be either a minimum or a maximum, because either that's the lowest point and everything else goes up, so that would make it a minimum, or it's at the very top, so it's the maximum and all the other points are going to be below it. We'll talk about the axis of symmetry. So again, that's just that vertical line where you're going to fold over, or you can fold the parabola over on top of itself. And it's just going to be x equals the number. It's going to be x equals h. Well, here we have 0, 0 for our vertex. So our axis of symmetry is going to be x equals 0, to where you're just pulling the x part of the vertex. One of the other things to make a note of is that they're calling the vertex h comma k. That's still your xy coordinate, but they're using h and k because that's going to be really helpful in some of the next formulas. So instead of calling it x1, y1, because we've already used that for other stuff, it's h and k. Okay, so the standard form of the quadratic function. So the standard form, here's where we have our h and our k. So it's a onto x minus h all squared plus k. This h and k are your vertex. Now the one big thing to keep in mind is this negative sign right there. That's a built-in negative. So what that means for you is that if anytime you're trying to pull the h and k, or the vertex, from an equation in this form, the h is going to be the opposite of what it looks like, because that negative is built in. So I'm going to jump down and look at a real quick, and then we're going to come back up and talk some more. But if we want to just find the vertex, and again, it's in the standard form. So it's x minus h, and h is going to be the x part. So it looks like minus 2. Yeah. So the x, or the h, is going to be 2. And then what's the k, or the y part? Yeah. One of the things I want to point out, so this is h comma k. And for our ordered pairs, we have x comma y. Both are alphabetical, right? Okay. If you're ever in doubt, it's probably alphabetical. That's true like through almost everything we're going to do. Okay. So, you know what? Let's do more stuff. So we have our vertex at 2, 12. And I'm going to do a super rough sketch. So over 2, up 12. It's going to open down. I know that because I have a negative in front. And then as far as this 3, that is going to make it steeper. Yeah. So it's going to, if we had our standard, all right, we're going to pretend that this is our, so if we, yes. All right, so we have the negative in front. That's going to flip it down, which hopefully you guys remembered, right? Because you just took a test on it. So if we have the 3, that's going to make it a little, everything's going to be steeper, meaning it's going to be skinnier. So it's going to pretend that's a really pretty but steeper parabola. Yeah, you're squeezing it inside. Uh-huh. Oh, you plug in a point. Oh, yeah, you do. So anytime you guys are trying to graph anything, just plug a point in. So if we've got our equation, f of x equals a negative 3 onto x minus 2 squared plus 12, I usually like to pick a point, so I like to pick an x that's 1 away from the vertex, or I pick x as 0. How about we'll pick x as 0? So that'll be our y-intercept. So we do f of 0 equals negative 3 times 0 minus 2 squared plus 12. So let's see, negative 2 squared is going to give us a positive 4 times a negative 3 is going to give us a negative 12. So we have negative 12 plus 12, or 0. So we're going to have the point 0, 0, which actually I kind of accidentally drew that. Just works out every now and then. But if you didn't pick that one, I mean, you can pick any point. So again, I like to pick 1 away from the vertex a lot of times. So I'm going to pick f of 1. So we're going to have negative 3 onto 1 minus 2 squared plus 12. So f of 1 equals the negative 3 times negative 1 squared plus 12. So the negative 1 squared is going to be a positive 1. Positive 1 times a negative 3 is going to give us a negative 3 plus 12, which is going to give us a positive 9. So we're going to have the point 19. So it doesn't really matter what you pick, because for you guys, you got to know the vertex. That's going to be the first thing that you have to graph. And then the second one is any other point that you can get on that graph. Is that okay? So you have to know the vertex. Because whenever you graph in my math lab, it asks you to graph the vertex first and then another point. And by graphing that other point, because of symmetry and everything else, they assume you can figure out the rest of it. Is that okay? Well, you guys seem thrilled. Good. All right, let's go back to that line of symmetry, or axis of symmetry. Call it the right thing. So the axis of symmetry, what's that going to be? All right, it's either going to be x equals or y equals. Which one? X equals what? Yeah, the h, or the 2. Because it needs to be the line that's running vertically through the vertex. Right? So that's going to be your line x equals 2. Is that okay? All right, well, good. I'm glad you guys are having fun. All right, you guys do B. I want you to find the vertex and also the line of symmetry. All right, so what'd you get for your vertex? 3, 1. And your line of symmetry, or your axis of symmetry? Yep, x equals 3. Is that okay? Okay, so sometimes they don't give you a nice, pretty standard form for your equation. You might get the general form, which we covered the general form on Wednesday, right? The ax squared plus bx plus c, because that's what we used when we were using the quadratic formula. So there's a trick, and it's this nice little fun thing here, that if you have it in general form, then using this will get you the vertex. It looks really horrible, but it's really, really not. So we're already in general form. So we know our A, B, and C. We don't need our C, but I'm going to go ahead and write it anyway. So what's my A? What about my B? Yep, and what about my C? All right, -1. Okay, so to find my vertex, the first part is going to be the opposite of B over 2A. So opposite of B over 2A. So it's a -12, or a +12, over 2 times A, which is 3. There, we'll work it in. So we got 12 over 6. So we got 2. If you know that much of your vertex, how do you get the other half? Yeah, plug it in. So we're going to do f of 2, which would be 3 times 2 squared minus 12 times 2 minus 1. So this will be what? 12 minus 24 minus 1. So did you guys get -13? Super. Does that make sense? Okay. So I'm going to go explain the big ugly thing up here now. This opposite of b over 2a, comma, f of opposite of b over 2a. That's what you guys just did. So the opposite of b over 2a gets you the x part, and then this says plug it in and get the y value. So this is saying f of whatever your x was. So this is saying plug it in and you'll get the other half. All right, you guys try b on your own. I'll give you a good minute or so. All right, so to find the first part of your vertex, the opposite of b over 2a. So did you guys have 12 over 2 times -2? All right, so 12 over -4 gave you a -3. Super. So we know this much. The vertex is either the maximum or the minimum, so the top or the bottom of the parabola. It depends which way it's opening. Right, so the way I always remember it's the opposite of b over 2a, which is the exact same thing as this. So negative and then the b over 2a is the same idea. Correct. So this is your a is the -2, b is the -12, and c is that +3. So it's a negative. So technically, if I want to look at, this is what I'm doing, then I have -12 over 2 times -2. So the -12 gives us a positive, and then 2 times -2 is going to give us that -4. So that's how we're getting right here. Is that okay? All right. All right, so we have half our vertex. To get the other half, we're just going to plug in. So we've got f of -3 equals -2, and then we're going to plug in that -3 squared minus 12 times -3 plus 3. So f of -3. The negative 3 squared will give us 9 times the negative 2 is going to give us a negative 18. And then plus 36 plus 3. So did you guys get 21? All right, good. So our vertex is going to be 3, 21. Yes, negative 3, 21. Thank you. I actually want to start with B first. And we'll work through B, and then I'm going to give you guys a couple minutes on A. So for B, we want to find the vertex. Well, the vertex is going to be easy. I'm going to go ahead and rewrite this to be in standard form. Is everybody okay with that? I just swapped the positions. It's going to be plus 4 because there's no sign here. So there's no sign. We assume that this is a positive 4. So to keep it positive, we have to show that it's a plus 4. The sign always goes to whatever is to its right. So we have this. Our vertex is easy. What do you guys get for your vertex? 1, 4. Is that okay? Because the opposite of what it looks like with the x is the x part, and then the random number all by itself is the y part, or your h and your k. Yeah? Okay. Which way does this thing open, up or down? Oh, it's going to face down because the negative in front, this negative right here, has it facing down because typically they face up, right? If it's positive, it'll face up. So this negative makes it face down. All right, and then it asks for the x-intercepts and the y-intercept. Let's do the y-intercept first. How do you find a y-intercept? So, right, it's where it crosses the y-axis. What do you know about the point that crosses the y-axis? Yeah, you know it's 0 something. You know the x is 0. So we can just do f of 0, right? Once you know half, you can just get the other half. So we're going to do f of 0. All right, so the 4 minus the 0 minus 1 in parentheses will give us a negative 1. Negative 1 squared gives us a positive 1. And then 4 minus a positive 1 is going to give us a 3. How was that for fun signs in your head? Yes. So whenever we come through, and I'll go ahead and here. So we've got 4 and then minus that negative 1 squared. That negative 1 squared is actually going to be a positive 1. So we end up with 4 minus, we don't need the parentheses, but I'm just showing them. So 4 minus 1 once we square it. So the 4 minus 1 is going to give you that positive 3. Is that all right? Okay, and then we need to find the x-intercepts. So the x-intercepts, what do we know is true about those? Yeah. We know that it's going to be something with a 0 for the y, and we may or may not have more than 1. We could have none, actually. We'll find out. So the way I'm going to approach it is instead of having the f of x equals this, I'm going to have 0 equals this. I'm going to plug in the 0 for the y. So we have 0 equals that negative. Oh, I switched back and forth. Sorry. Are you guys using the top one or the bottom one? Are you guys using this one or this one? Okay. Well, good. I've got half and half. Awesome. We're going to use this one that I meant to use to begin with because it's in standard form. So we have the negative parentheses x minus 1 squared plus 4. Now, how do you all know to solve for x whenever something looks like this? Okay, we can get the x by on one side. I'm going to move this down. Hang on. So now we have plenty of space. All right, so to do that, we're going to move this 4 over. So we're going to subtract 4 from both sides. So then we have a negative 4 equals negative x minus 1 squared. Now what? Got to get rid of that negative first, and then we'll get rid of the square root. So to get rid of this negative, I heard divide by negative. We can't distribute because that's squared. I know, it's tempting, but the exponent wins, so you can't distribute if there's an exponent. So we end up with positive 4 equals x minus 1 squared. All right, square root. So the square root of the left side gives me what? What's it give me? There we go. Plus or minus 2 equals x minus 1. And then we're almost there, right? Thank goodness. Because we started with a square, and we're having to take the square root. So we're using the square root property, and I can't remember if that was Wednesday or last unit. Yeah, the actual day blurs for me. But whenever you take the square root of something that was squared, you're going to do plus or minus. Because if we square positive 2, we're going to get 4. But if we square negative 2, we're going to get 4. And since we're talking about something squared, and we're taking the square root to solve, we're going to do plus or minus. You don't always have to have 2 solutions. You could actually, we're going to have somewhere between 0 and 2. So you can have 0, meaning they're imaginary. You can have 1, meaning that the vertex touches the x-axis. Or you can have 2, meaning that it actually crosses it twice. This one's going to have 2. So we end up with 1 plus or minus 2 equals x. So that means that we're getting x equals, so 1 plus 2 is 3. 1 minus 2 is going to be a negative 1. So the x-intercepts are actually going to be 3, 0 and negative 1, 0. Is that all right? No? Okay. What you could have also done, if you had gone through and just worked this out, you would have gotten it, and you could have gotten it into general form, and then you could have factored it, or you could have gotten it into general form and then used the quadratic formula. So those options will also get you the 3 and negative 1. Right, 1 plus 2 gives you 3. And then 1 minus 2, because that plus or minus means you have to go through twice. Yeah. No, for some reason everybody hates the plus or minus sign. You guys like the shorthand, but you don't want it to mean anything. Is that all right for the x-intercepts? Did we do everything? Oh, and for fun, your axis of symmetry is what? Yeah, x equals 1. All right, so axis of symmetry is x equals 1. We knew that from the vertex. We have a y-intercept of 0, 3. And we have x-intercepts of 3, 0 and negative 1, 0. So that's more than enough information for us to graph this. So 1, 4. So 1, let's see, 1, 2, 3, 4. You guys already told me it faces down, but hopefully you're going to figure that out anyway. So we go 3, 0 and negative 1, 0. You told me that my axis of symmetry was the x equals 1. And you said that the y-intercept was what? Okay, so 0, 3. Because I have my axis of symmetry running through here, I know if I have this point, so from this axis of symmetry I want one to the left, I can also go one to the right, and I know that this point will be there also, just to kind of help draw it a little bit better. And then just connect them as best you can. Is it always like what? All right, you guys try A. All right, let's get started with it. So how'd you find the vertex on this one? Super. All right, so we had a negative, negative 2 over 2 times, and our A was just that 1. So we had 2 over 2, or just 1. So the vertex we have is 1 something. How do you find the other part? The B is a negative 2. So what's happening is we do a negative, negative 2 here. So we really have this going on. So the 2 negatives will end up canceling out. All right, and then I heard to find the second part, plug it in. So we're going to do, oh, I was trying to say the same color. So we have f of 1 equals 1 squared minus 2 times 1 minus 3. Let's see, we're going to have 1 minus 2 minus 3. I'm not sure why I closed parentheses. It didn't exist there. Sorry. So negative 4? Okay. Okay. So we have our vertex. And let's do the y-intercept next. How'd you find the y-intercept? Yeah, you know that x is 0. So if we do f of 0, we're going to have 0 squared minus 2 times 0 minus 3. So did you guys get f of 0 is negative 3? Okay. All right, so there's our y-intercept. And let's do our x-intercepts. How'd you find your x-intercepts? All right. So we know that 0 for the y. So we have 0 equals x squared minus 2x minus 3. How do you solve that? I would just factor it. And then, so we know we're going to have opposite signs to multiply that negative 3. And then we need to add to a negative 2, so we're going to have a 3 and a 1. Which one's going to be negative? Yeah. Yeah. So negative 3 plus 1. Are you done? No. You're going to take each factor, set equal to 0. And then solve. So now we move this over, we're going to get x is 3. And then we move this over, we're going to get x is negative 1. Unless I ask you which of these steps. So we end up with our x-intercepts being 3, 0. That's a comma. And negative 1, 0. All right, let's graph this guy really quickly. So we have 1, negative 4. And then we have our y-intercept at 0, negative 3. We have our x-intercepts at 3, 0. And at negative 1, 0. Because I know that this thing's symmetric, I can put another little dot right here. right? This is our little bonus dot from knowing that this thing's symmetric. And our axis of symmetry is just going to run straight through the vertex. Can you guys see that it's going to be a parabola that faces up? Okay, good. Yeah, this is like I said, it looked like a short page, but a lot of parts to it. Yeah, 20 steps. One problem done. But super good news. This page is going to be super easy. So it's word problems, but it's good word problems. Now hang on. Now, quit with the attitude. These are good. So these really are. So here's what it's telling you. It's saying that there's a function that has something to do with the situation they've given. And it's going to be a parabola. And then they're going to ask you, what is the most amount of money you can make? Or what's the least amount of money you can make? Or what's the most number of pretzels you can bake? Or what's the least number of video games you can rent? Or whatever. But everything's going to be most or least. And if this is a parabola, what do you think most and least is referring to? It's referring to your vertex. So these word problems, as long as you're figuring out what the X and what the Y stand for, you're good. So for the first one, the owner of a video store has determined that the cost, C, in dollars of operating the store is approximately given by C of X equals 2x squared minus 28x plus 690, where X is the number of videos rented daily. All right, so I'm going to write down X is the number of videos, and C of X, which is the same thing as our Y, they said was the cost. I'm labeling my X and Y because this is probably the biggest mistake I see you guys make. You'll go through, work the problem properly, and then pick the wrong number. So it says find the lowest cost to the nearest dollar. Well, you guys know it's a parabola because of the squared. It has a positive number in front of the X squared, which means it'll face up. So if it's a facing up parabola, it has a minimum. And that's all it's asking us to do. So we're going to find the lowest cost to the nearest dollar by finding the vertex. So opposite of B over 2A. So that's going to be a negative 28 over 2 times 2, or 28 fourths, which reduces down to, okay. So for our vertex, so far we have 7 comma something. So to find the something, we're just going to plug that 7 in. So we have C of 7 equals 2 onto 7 squared minus 28 times 7 plus 690. 592. Does everybody agree? Must be right. It does not work on tests, by the way. So C7 is 592. All right, so, yes, so this is the minimum cost to run the store. The X's is the number of videos, saying that if we rent 7 videos, the least amount of money to run the store is going to be $592. But regardless, your answer would be the 592, because it's asking for the money. All right, we're going to go ahead and bounce through number 2 really quickly. All right, so an object is propelled vertically upward from the top of a 32-foot building. So if you want a visual, here's your building, object, you threw it up there, and then it came back down. Objects are going to travel in parabolas, just so you guys know. The quadratic function is given. S of t equals negative 16t squared plus 224t plus 32. Models the ball's height above the ground, s, in feet, and then t seconds after it's thrown. So t equals the seconds. and S equals the height. Now, this is an example where it's not necessarily alphabetical. So the T is where our X's normally are. Yeah? So that's our X. And then our Y is where the S of T is where the Y usually is. So just to kind of keep it in perspective. So we want to find when it reaches its maximum height. So let's do that part first. Still same idea. It's a word problem. There's a quadratic. It mentions the word maximum. You know that your parabola faces down. You're just finding the vertex. So we're thinking opposite of b over 2a. So that's going to be a negative 224 over 2 times a negative 16. Super, thank you. And then we're going to plug that in, which, by the way, 7 means 7 what? 7 feet, 7 seconds? Yeah, 7 seconds. So S of 7 equals that negative 16 times 7 squared plus 224 times 7 plus 32. Did you guys get 816? All right, then I must have gotten the calculator right. So S of 7 is going to be 816. So the max height was what? Yes. So 816 feet. And what time? So 7 seconds, and that's going to be 7 seconds after it was thrown. The way these get tricky, this one wasn't too bad, is they'll go through and they will only give you one question, meaning they would go through, give you this whole thing and say, when does it reach its maximum height? The when is asking for the time, which is the 7, which we got from the opposite of b over 2a. And a lot of times, students will go through, they'll do that, they'll get the 7, they'll plug it back in, they'll get 816, and regardless of what the question was, they will answer 816. Because you think that all these questions or all the problems have to be equally long. Sometimes they're short, and those are the ones that catch you guys.